Hello everybody. Today what we're going to be discussing is how we're going to create polynomials from the zeros of a polynomial. Now remember, a zero is a commonly used term that basically says that's the solution, that's where it touches the x-axis, that kind of thing of any polynomial. So this, let me get my pen. This guy right here, this would be known as a factor of the polynomial. And so if we were to solve it, we would get x is equal to c. So for instance, if I have a factor that is x plus 3, this is again a factor. Well, if I set that factor equal to 0 and I solve for it, I get -3. This is known as a 0, a root, a solution, an x-intercept. All of those things essentially refer to the same thing. It's just where does a function touch the x-axis? 0, root, solution, intercept, it's all basically the same thing. Here, make sure that you pause the video as appropriate for you to make sure you get this stuff copied down. But basically, you're going to be working with factors. You're either going to be given a 0 and create a factor, or you're going to be given a factor and make a 0, that kind of thing. So if your 0, your solution, if it's a negative number, then when we write the factor of it, we just change the sign to make it positive. If the root or the solution or the 0 is a positive value, then when we write its factor, it would also change signs and be a negative. And we are going to be doing a whole lot of multiplying, FOILing, distribution, so that way we can get rid of parentheses, because what we're going to have is a bunch of stuff, we're going to have a bunch of factors. We're going to have to multiply all those factors together to put it in, standard form, where we would have something like f of x is equal to x cubed plus 4x squared, etc. Something in standard form, not in factored form. And of course, at the bottom, we have the difference of two squares shortcut, if it helps you. Now, here are very typical types of questions that you're going to see on your assignments, on your quizzes and tests, that kind of thing, where it's going to say, okay, we have these solutions. We want to create a polynomial in standard form that is a degree of 3. Now, I've been using this term degree as often as I can because we're going to be using it quite a lot when we're talking about polynomials. A third degree polynomial essentially says I have to have something x, y, whatever the variable is, we have to have something to the third power. The degree also tells you the number of solutions that the polynomial should have. And in this case, that's why we have 3 numbers, because if I have a third degree polynomial, I have to have 3 solutions. Whether they're all real or there's some real and some imaginary, there has to be 3 solutions no matter what if the degree is 3. So in this case, we have 3 real solutions. If we were to graph this, we would see that the polynomial would touch the x-axis at a +1, a -4, and a +2. And we'll get to that a little bit later on, because that's one of the reasons that we want to know what the zeros are. That's one of the reasons why we're doing synthetic division, so that way we can see what are the roots, what is a factor of a polynomial. But let's get back to the task at hand. Here we have the 3 solutions that are given to us, and what we need to do is write the function in factored form. So based on what we saw on the previous slide, this 0 is a +1, or the solution is a +1. So if I write it in a factor, I'm going to say x minus 1. The second solution is a -4. So if I write its factor, it would be x plus 4, and the last one would be x minus 2. Now, here, if we said f of x is equal to something, this is the polynomial in factored form, which is going to be something that we're going to be working to at some point. We're going to write a polynomial in factored form at some point. But for now, we're going to take the solutions that they gave us, write the function in factored form, and now what we need to do is multiply everything together so we can put it, ultimately, in standard form, because that's really what this exercise is asking us to do. Now you can see we have three linear expressions. We have x minus 1, x plus 4, and x minus 2. What we need to do is multiply all these things together. There's nothing saying that we have to multiply from left to right or from right to left or whatever the case. Ultimately, these things are all going to be multiplied together. But in my experience, I believe it is helpful to start at the right side of the problem and work our way to the left. Meaning that I'm going to take these two, multiply those together first, and then whatever the product of those are, I will multiply the last factor to it. So essentially what we have are two linear expressions that we're going to FOIL together. The x times the x times negative 2, and the 4 and the x, and the 4 and the negative 2. So since I'm not doing anything with the x minus 1 yet, I'm going to just bring it down to the next row, saying, hey, we're going to have that there. So when I FOIL these together, x times x is x squared, x times negative 2 is negative 2x, x and 4 is a positive 4x, and 4 and the negative 2 is negative 8. Combine any like terms that you have, and always we're going to have the middle terms as like terms. So x squared, negative 2 plus 4 will be plus 2x, and then the minus 8. So we've multiplied the last two terms together, and we wound up with a new quadratic. And what we're going to do now is take the last function, or I'm sorry, not the last function, but the last factor, and multiply it to the quadratic on the right. Now, here there's not a nice acronym like FOIL does, or like FOIL is when we teach it to you in Algebra 1. We just say FOIL to help you kind of remember, how you multiply it. But essentially, the x of the x minus 1 term has to get multiplied to every term. And so does the negative 1. The negative 1 also has to get multiplied to every term. So there's not like a nice acronym for that. But that's essentially what we're doing, is we're taking the x, multiplying it to everything in the parentheses on the right, and then taking the negative 1 and doing the same thing. So x times x squared is x cubed. X times 2x is a positive 2x squared. And then x times negative 8 is negative 8x. Now here's where I'm going to do something just a little bit differently than maybe what you've seen in some of your other algebra classes. Normally what we would do is we take the negative 1 and we would say minus x squared when we multiply it. And we would just kind of finish it out and write everything in one row. What I'm going to do is slightly different, and I'm hoping it will be something that will help us identify our like terms a little bit better. What I'm going to do is all the products that I get when I multiply the negative 1 to everything in the right side of the parentheses is I'm going to write it underneath what I've already written, so that way I can see what my like terms are going to be and combine them a little easier. So negative 1 times x is negative x squared. So I'm going to write it underneath the x squared term that I already had before. And negative times positive will give me minus 2x, and then negative times negative will give me a positive 8. And now we can see our like terms, what combines a little bit easier. So top to bottom, there's nothing underneath the x squared, so x squared plus 0 is just x cubed, not x squared. Positive 2x squared minus 1x squared will be a positive 1x squared. Negative 8 minus 2 will be a minus 10x, and then 0 plus 8 is just plus 8. So here, the final function in factored form is just x cubed plus 1x squared minus 10x plus 8. And so that's what we've gotten. Now what we've practiced before is we've tried taking, can we factor by grouping? Can we factor by, some other methods? And ultimately what we've wound up going back to are what were the solutions. Well, now we're kind of looking at it from the opposite directions. We're saying, okay, these are the solutions. What would the function be? So here, another pretty much standard example that we could expect to see in this class. You see in the solutions that are provided for you that they're giving you two numbers that are not whole numbers or integers. They're giving you radical numbers as well, which, from the quadratic formula, we've seen plenty of answers that are in radical form. So there's no reason to say why we can't do this here. So again, the degree 3 says there has to be 3 solutions. In this case, we have 3 real solutions. So 3 for my degree says ultimately I'm going to have something that is x cubed. So let's go ahead and write these in standard form. The positive 4 as a factor, I'm sorry, let me back up. Let's write these in factored form. The 4 will give me x minus 4 as a factor. The 3 radical 2 will give me x minus 3 radical 2. And the minus 3 radical 2 in factored form will be x plus 3 radical 2. So again, I tended to work these problems always the same way. I think it's easier for us to multiply from the, when we have multiple factors that we have to multiply together, I think it's much easier to start at the right and work our way to the left. So again, I'm going to multiply the two factors on the right first. So we can say this is f of x is equal to something. We're not going to multiply with the x minus 4 yet, so I'm going to just bring that down. So here, if we FOIL the two expressions together, x times x is x squared, plus 3x, or plus the 3 radical 2 is going to be plus 3x radical 2, and then negative 3 radical 2 times x will be minus 3x radical 2, and then this is where some of us are going to have an issue. Don't forget you have to multiply the whole numbers and the radicals together. Negative 3 times negative 3, or positive 3 is a negative 9. Radical 2 times radical 2 is the square root of 4. So let's simplify the stuff in the parenthesis on the right. Here, the like terms, positive 3x radical 2, negative 3x radical 2, those cancel each other out. They're opposites. And so now I'm going to have minus 9, and the square root of 4 is just 2. Go away. So I'm going to say the square root of 4 is 2, so I'm going to simplify that. And now we have x minus 4, parentheses, x squared minus 18. And so now everything for our first, factors that we multiplied have been simplified. Now we're going to kind of multiply here. Again, if you want to think of this as foiling, you can, because essentially these are two binomials. But everything in the x minus 4 parentheses must essentially be multiplied to everything in the x squared minus 18 parentheses. So x times x squared is x cubed. X times negative 18 will be minus 18x. And here I'm not going to write this in the same exact order that I did on the first example, because there just aren't going to be any common terms that we can combine, or any like terms that we can combine. So this will give me negative 4x squared. And then negative 4 times negative 18 is going to give me a positive 72. So the only thing I'm really going to do differently is, writing it in standard form, we put the exponents in order from greatest to least. So I'm going to say minus 4x squared minus 18x plus 72. And so here is the function in standard form. And the last example, so here, this one I want to make sure you see, because this one is giving us a degree of 4. That means ultimately we should have something x to the 4th power when we're done. And because it is a degree 4, there should be 4 solutions, whether it's a combination of real or imaginary. There has to be 4 in one way or another. So here we have 4 real solutions. Write them in factored form. So we'll say f of x is equal to, here the first solution is going to give me x minus the square root of 7 as a factor. The next one will give me x plus the square root of 7 as a factor. X minus 3 for the third one. X plus 1 for the last one. Now in this case you can follow the exact same method that I've done before, meaning you start multiplying these two together, and then you could multiply the next factor to from the left to the right, and then the last factor from the left to the right. But when we have an even number of factors like this, I think it's easier to just FOIL both pairs at the same time. So that's what I'm going to do. So x times x of the first two factors gives me x squared plus x square root 7 minus x square root 7, parentheses. And then negative square root 7 times positive square root 7 will give me negative square root 49, which, you're going to see that's going to just simplify to be a 7 anyway. So FOIL the last two factors, x squared plus x minus 3x minus 3. And now we will simplify everything that we can inside of the parentheses. So x squared. Here, these are opposites and they cancel each other out. And the square root of 49 is just 7. And here in the second parentheses, the like terms are going to give me negative 2x minus 3. Okay, and moving on. Oh, I'm sorry, I lost my train of thought for a second. Okay, let's keep going. So now we have simplified both of the parentheses that we have. And so again, there's not a nice acronym multiplying these two expressions together, but basically everything in the parenthesis on the left has to get multiplied to everything in the parenthesis on the right. So x squared times x squared gives me the x to the fourth for my degree that I'm ultimately looking for. X squared times negative 2x will be minus 2x cubed times the negative 3 will give me minus 3x squared. Do the same thing with the 7. Negative 7 times x squared will give me negative 7. Oops, wrong column. Negative 7x squared. Negative 7 times negative 2 will give me a positive 14x. Negative 7 times positive 3, or negative 3 will give me a positive 21. So again, I think it's easier sometimes to write it like this so we can see what our like terms are going to be. So you can see x to the fourth doesn't combine with anything, so we have 1x to the fourth. The negative 2x cubed doesn't combine anything, so minus 2x cubed. Negative 3 and negative 7 give me minus 10x squared plus 14x plus 21. And so here is the final factor in a fourth degree polynomial, in fact, or in standard form. So essentially, it doesn't really change from what we're doing there. We can make it more complicated by giving you imaginary roots instead of just all real roots, but it's not something that we are really going to have to get into right now. So if you have any questions, make sure you get them written down and come see me in class with any questions that you have. Otherwise, we'll see you in class soon, and thanks for watching.